All right, let's go to the next one. All right, the next parent function we want to talk about is y equals the square root of x. Okay, now this one's going to be a little bit special because not all domain values will work inside of this function. Okay, for instance, if you set up your t-chart, the very first x value I choose, -4, is undefined. And the reasoning is this: you cannot take the square root of a negative number. So when you set up y equals the square root of -4 and you try to put that in a calculator, it's going to come back as an error or undefined. So that point will not be able to be, it will not be plottable. Okay. So with that in mind, take the rest of these domain values, pause the video, and complete the t-chart for y equals the square root of x. Go ahead. Okay, guys, you got your t-chart finished for y equals the square root of x. Let's check our answers here. All right, -1. Again, once again, you cannot take the square root of a negative number, so that one is also undefined. We can take the square root of 0 and we get out of 0. We can take the square root of 1 and that gives us 1. We can take the square root of 4, that gives us 2. And we can take the square root of 9, which gives us 3. Last but not least, we can take the square root of 16, which gives us 4. If you notice, these numbers here I chose for a special reason, and that's because they are all perfect squares. It's really easy to take the square root of a perfect square. Okay, so we do have some order pairs that we can plot here. So now's the time on the video. Pause the video, plot your points so we can see what the graph of the function y equals the square root of x looks like. Go ahead and pause the video. Okay, let's take a look at the graph of y equals the square root of x. Because we cannot take the square root of any x value that is less than 0, there's nothing on this side of the graph. We start at 0, and then our graph begins a curve up and to the right. Okay, so it's I don't know if we can really describe it as a shape or a letter, but this is a square root function. You need to put that in the description, and that put a note that you cannot take the square root of a negative number. Last parent function, y equals the absolute value of x. Absolute value is defined as the distance away from 0. Okay, so in this case, how far is -16 away from 0? Well, it's 16 jumps. So put in a -16, get out a +16. A lot of kids remember that absolute value, you just get rid of the negative and it's always the positive answer. Okay, so fill out your t-chart, set it up, pause the video, and complete the t-chart for this specific equation, y equals the absolute value of x. Okay, you got your t-chart complete. Let's check and see what you got. Again, absolute value is how far you are away from 0. So plug in a -16, get out of 16. Plug in a 7, get out of 7. Plug in a 3, get out of 3. Plug in a -1, get out of 1. 0, 0, 2, 2, 6, 6, 12, 12. Okay. You can plug in any negative or positive input value or domain value and get out a nice range value. But notice all the range values are also positive. They're always going to be positive in this case. All right, take those order pairs and complete the graph for y equals the absolute value of x. All right, last graph, y equals the absolute value of x. Here's the points that we have from our t-chart. I plotted them. It is a straight line coming down, and then it goes up in the opposite direction, and it makes the shape of a V. So absolute values make the shape of a V. So make sure you put that in the description there. Also understand that if you take the absolute value of x, you're not going to have any negative range values. And with that, that ends up. I told you this was going to be fun. What we're going to do in the future is we're going to take these parent functions and we're going to adjust them ever so slightly and see how the adjustments affects the way that the graphs look. All right, see ya.